together like that. There is one cube. Two cubes. So the double corners, 12 of them can make 2 cubes. Synergetics cannot make 1 cube. Only the hexahedron, but it's not a cube. And this is so we clearly see what is the true minimal scale, and we also see what Fuller always emphasizes on: do more with less. It's actually not true in synergetics. It would rather sound like do less with more, and that's what synergetics can accomplish. So there are inconsistency because our synergetics cube is this big. This is my cube. This is, let's say, synergetics cube made up of these A modules like that. And then this octant, this black one, is composed of 12 blocks. So 12 times 4 is 48 and 24 is 72. So we see what's a true minimal scale. Here I want to show, this is a cube, this is a cube octahedron. There are also problems with the duotet cube. This is a David of star. I mean Star of David, I don't know, I always say it reverse. This is a Star of David, and this one is composed of 14 spheres, and there is no doubt about that. I'm going to remove these just to show that indeed, I'm just going to do it like this, that this tetrahedron, this regular tetrahedron in my scheme, this one is 4 spheres, this one is 10 spheres. Now we're going to add regular tetrahedrons on it, and we're going to count the spheres. So we said the regular tetrahedron has 10 spheres, then we have 11, 12, 13 and 14. So this David of star is made up of 14 spheres, and this is a duotet cube. These are same volume identical blocks as this regular tetrahedron. So we have 8 blocks in a regular tetrahedron, 8, then we have 9, 10, 11, 12 other tetrahedrons, so that's 12, and then we have 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. But since Synergetics claims that the regular tetrahedron is only 4 spheres, the duotet cube is impossible in Synergetics to be made up of 72 blocks. You would have to have 72 times 8, which would be 570, 76 or something like that. In other words, this cube would have to be in a 2 frequency, stacked up 8 of these cubes, and then you could make it start a duotet cube. Now, to claiming that the Synergetics duotet cube has 72 blocks is just absolute wrong claim. It's not true. The same thing applies to this cube octahedron. Now in Synergetics they claim they have a cube octahedron made up of 60 blocks, which would be like this. This is a cube octahedron. Now, before I take it apart, you guys see that these are same cubes. This one was 14 spheres. That's a duothet cube. This cube is cube octahedron, and this one, as you see, it's a cube octahedron, and this one is made up of 12 spheres. We can count them. 1, 2, 3, 4. That's 4. Then we have 5, 6, 7, 8, 9, and then we have 10, 11, and 12. This one is composed of 12 spheres, and one sphere is on the inside, which I'm gonna demonstrate if I can. Okay, no, that's gonna be a wrong division. Let me do it like this. We're gonna cut it on the hexagonal plane like this. That's half of the cube octahedron, and then we're gonna have, I guess, like this. The regular tetrahedron. Now we see that there is other sphere inside of this, because these are prime vectors. So there is actually 3 spheres in this section. 1, 2, 3. So we have one sphere in the center. It's called also a nucleated cube. So if you consider spheres, there are 12 spheres going to surround this one. But we said that this one is 14 spheres, and this one is then 13 spheres. Now we're going to put them back to the cube octahedron, which is this one. But again, this is impossible in Synergetics to have, because they don't have this regular tetrahedron, this 1/8 regular tetrahedron. So again, to make a cube octahedron, you would have to have a 2-frequency cube like this. If this is a 1-frequency cube, you would have to build a 2-frequency cube, and then you could remove the 12-block octant, and then you would have a cube octahedron, but it definitely wouldn't be 60 blocks like they claim. Now, but what I want to show something very important, and no one have obviously seen this before, and I myself have not, but this was done just by the coincidence or little accident, and many times some things are invented or observed by the virtue of the accident. In other words, errors are sometimes good. They help you realize something. One day I had these 2 cubes constructed. I don't know what I was working on, but I had this duothet cube, and then I had this cube octahedral cube. And as I said, 13 spheres, 14 spheres. So seemingly they are 2 different cubes, but I want to show something very important. So this cube octahedron, it's actually it's 60 blocks in Synergetics, and it's equivalent to 2.5 regular tetrahedral volumes. Since in Buckminster Fuller's scheme, the regular tetrahedron, this one is the volume unit, but the large one, 24 blocks, so 2.5 would equal to 60. So they say the cube octahedron is equivalent to 60 blocks if we would remove these. Well, in my scheme it's 40 blocks, since a 2-frequency cube is 48, and you remove 8 corners just like that.